Yes, welcome back to the next session of design of prestressed concrete elements. In the last session we have been discussed the definition and the historical development or how this concept has been evolved in the mind of a civil engineer. Then we have been discussed the various, there is a concept of prestressing. Have been discussed both pre-tensioning prestressing system and also the post-tensioning prestressing system. So we will today further discuss all those prestressing systems. So before getting into these types of prestressing system, first we need to know some of the terminologies. Without knowing these terminologies, we are not able to understand the concept, or else I can say the various types of prestressing system, because they are used to use the terminologies called strands, tendon, eccentricity, all those things, or anchorages. So if I am going to define or if you are going to learn these terminologies, okay, you will be more familiar with this. Not only this, okay, these terminologies we are going to use in the entire course of design of prestressed concrete elements. So with this, let us get into the terminologies used in PSC. So let me define one by one. Okay. So the first terminology is, I always use this word, wires. Okay, number one, because here majority of the time I am going to use wires of so and so dia. Okay, so what is the meaning of wire? Wire, it is a single unit made up of steel. It is a product, it is a single unit, okay, made up of steel. It is called as wire. And it will be of different diameters, okay, 2 mm, 3 mm and so on. So this will be called as wire. It is a single unit made up of steel. Next, the second terminology is strands. S-T-R-A-N-D-S, strands. So what is the meaning of strands? 2 numbers, 3 numbers, or 7 number of wires. I will repeat. 2 numbers, 3 numbers, or 7 numbers of wires are wound. Simply they are not being joined, are wound to form a single strand. Okay, or else strand. Okay. If 2 number, 3 number, or 7 numbers of wires are wounded to form a strand, a single strand. Did you get my point? So the next is tendon. So this is a very, very important terminology, tendon. So what is the meaning of tendon? Now, a group of strands or a number of strands or a number of wires are wound to form a tendon. Is it clear? If a group of strands or a group of wires are wound, that is a very important terminology we need to understand here. So that will be wound to form a tendon. I hope you know that in the various threads. Okay, so that various, okay, that one single thread, maybe you might have seen the day-to-day life that particular thread, okay, will be, okay, wound with a number of threads. Okay, number of threads. So that number of threads will be wound, okay, so that the bonding between them will be strong, so that the tensile capacity, why they are going to wound like that? Because by wounding this number of strands or wires in a proper direction or in a proper way, the tensile capacity of the strands or a tendon will be more. So that's why they are always going to wound them. That means a bunch of wires, a bunch of strands, a group of strands will be wound. Is it clear? Next. The next terminology is cable. Okay. So what is the meaning of a cable? A group of tendons will form a cable. Now, if all those group of tendons will be joined together, so that will form a cable or prestressing cable. Okay, so this is the important terminology. First you need to understand what is the meaning of wire, what is the meaning of strand, what is the meaning of tendon, and what is the meaning of cable. I will repeat. Okay, so the wire is a single unit made up of steel. If 2 numbers, 3 numbers or 7 number of wires are wound to form a single strand. Next, if a strand, that means a group of strands or a group of wires will form a tendon. If group of tendons are joined together, it will form a cable. So these are all the reinforcement, okay, that will be embedded. So this is the reinforcement or the terminologies, okay, that will be embedded inside the concrete. In RCC, you might have learned that the steel will be embedded. So here, instead of using a steel reinforcement, we are going to nomenclature a reinforcement as tendon or a cable or a strand or a wire. Is it clear? So I always say that a tendon of so-and-so diameter, a cable of so-and-so diameter will be embedded inside the concrete. So through this cable or a tendon, I am going to induce a prestressing force. I am going to induce a prestressing force, that is compressive prestressing force. Okay, in order to create a pretension, So these are all the devices, okay, or the reinforcement in which I am going to create a pretensioning, so that it will create a compressive stresses by bonding of tendon and a concrete. So this is what the thing we have been learned in the last session. Hope the terminologies have been clarified. Next, we will move on to the next. The next is anchorage. Anchorage. So now, in the last session, I used to anchor these tendons or at one end or at the either of the ends. Am I right? In the last session I have been drawn that precasting bed, and above the precasting bed we join with the abutments, and then these tendon will be erected, and those tendon will be anchored at one end or at the both ends. Why? In order to create a pretension in the tendons or a cable. Okay, so with this, let me define what is that anchorage. So it is a device generally used to enable the tendon to impart and maintain pre-stress in the concrete. I will repeat, it is a device generally used to enable the tendon to impart and maintain the pre-stress. That means whatever the pretension or pre-stressing that has been imparted inside this tendon, so those imparted stress in the tendon will be maintained throughout its service life. In order to make that, these tendons will be anchored at the ends. So this imparting pre-stress in the concrete at the ends will be possible through these devices. So I will discuss more detail upon this regarding these anchorage devices. Because in post-tensioning prestressing system, the Anchorage Devices plays a very important role. Why? Because in post-tensioning prestressing system and also in prestressing system, we are going to use different types of anchorages. In order to impart the prestress in the concrete. Okay, so that we are going to discuss. Okay, I hope you came to know the anchorage is a device used to impart and maintain the prestress, okay, in the concrete. Is it clear? Next, we will move on to the next terminology, that is pretensioning. So this have already been explained with a diagram. So once again I will repeat. So pretensioning is one of the type of prestressing system. So please note this point. It is the one of the method or type of prestressing system in which the tendon or cable are first stressed and later on the concrete will be poured. That type of system is called pretensioning. As the name itself, it is indicating that tensioning the tendon before the concrete is being placed. Before the concrete has been placed, I am going to tension the tendon. So that type of system is called pretensioning prestressing system or pretensioning. Did you get my point? This you should not forget, because in the entire course, okay, we are keep on using these terminology, that is pretension, post-tension beam, pretension beam. Okay, you should understand first what is the meaning of pretension. So pretension is first place a tendon, okay, and stretch it in order to create a pretension, anchor it, and then pour a concrete. That means after stretching the tendon, later pour a concrete and allow it to harden for number of days, and later on, as you know that I will draw the diagram, after attaining a concrete a sufficient strength, the jack will be released. The jack will be released. It may be mechanical jack that I am going to explain now. Okay, mechanical jacks, hydraulic jacks. Okay, number of devices will be used to tension it. Did you get my point? Okay, so whatever the diagram I have been drawn on the last class, that is a mechanical hydraulic jack in which after tensioning the tendon, the jack will be released. That means after tensioning the tendons and after concrete has attained sufficient strength, that means after curing the concrete for prescribed number of days, that is 28 days, later on the jack will be released. Okay, so that whatever the tension that has been induced inside the tendon, which is embedded inside the concrete, that should maintain the pre-stress throughout its service life without undergoing change in length. So that is what the concept of pretensioning. Did you get my point? I think I have been explaining the concept, okay, with the diagram in the last session. Okay. And once again, we are also going to discuss these with a type of pretension system. Next, we will move on to the next, post-tensioning. So what is the meaning of post-tensioning? Exactly opposite to that of pretensioning. What is that? Now, in this particular pretensioning, the tendons are stretched first, pretension is applied, and later concrete is poured. But in this case, in the post-tensioning case, first the concrete has been casted and allow it to get hardened for sufficient number of days, and later the cable or tendons will be tensioned against this hardened concrete. That is what the methodology in the post-tensioning. I will repeat. First cast the concrete and allow it to cure for sufficient number of days, and later the cable or a tendon will be tensioned against that hardened concrete. How? that has been explained that also in the last class. Okay, while casting the concrete, allow the sufficient gap. Okay, that gap is called as duct. What is the, why we need to provide the duct? What is the function of the duct? Okay, that duct has been, will serve the purpose in such a way that whatever the cables or tendons you are going to tension, okay, that cable will be inserted through the duct. The cable will be inserted through the duct. That means that is the space made for a cables or high tensile wires which will pass through the duct. Is it clear? And later on, after sending these high tensile wires, they are going to tension these high tensile wires with a varieties of a number of ways. It may be through mechanical way, okay, or it may be through that what I am going to explain in the next, okay, topic. Okay, how these tensioning of tendons will be made, or how the anchoring of this, what I can say, the tendons in the pretension case or in the post-tension case. That's what you need to understand. Okay, so this is what regarding the post-tension. Okay, I hope you came to know what is the difference between the pre-tension and post-tension. Okay, next we will move on to the next bonded pre-stressed concrete. Bonded pre-stressed concrete. So now, bonded pre-stressed concrete means a concrete in which the pre-stress will imparted to the, okay, I repeat, okay, a bonded pre-stressed concrete is a concrete in which the pre-stress will be imparted to the concrete through the bonding between the tendon and the concrete. That means, in the pretension case, the very best example for bonded PSC is pretension. Okay, so the bond always in the pretension we go with the bonded technique. That means, okay, whatever the tendon I am going to, okay, induce inside the concrete, okay, and I am going to do the pretensioning, okay, and afterwards I am going to put the concrete, okay, that means the bonding between the concrete pour and the tendon stretch, okay, will make, okay, the bonded PSC. More the bonding, or I can say stronger the bonding, better will be the behavior of pretensioned beams. Okay, I think in the last class also been explained, whatever the tensioning have been made in the tendon, okay, by stretching the tendon, okay, so those stretched tendon will be, okay, will be maintained as it is by pouring the concrete in such a way that whatever the concrete that has been poured, that concrete will get bonded to the stretched tendon, so that it will not allow the stretched tendon to get deformed or come back to its original length. Okay, so that bonded of concrete and a tendon will serve the better of pretensioning. Is it clear? So this is what bonded. So the bonded PSC, the best example is pretension. We will move on to the next. Next is unbonded pre-stressed concrete. Unbonded means it is a method of concreting, or it is a method of what I can say the pre-stressing, in which the tendon and a concrete is not bonded. I will repeat. It is a method, okay, of concrete in which the tendon and the concrete is not bonded. The very best example is post-tensioning. Why? Because in there, okay, first I am going to cast the concrete, later on I am going to put the is called unbonded. Okay, and later on, as I showed in the figure, in order to create the bonding, the tendon and the hardened concrete will be grouted. Okay, that means entire that whatever the cable that is there, that will be embedded inside the grout that has been placed. But the tendon placed inside that, the tendon placed inside the duct and the concrete that has been poured is not bonded. That is called unbonded. Okay. So this is called unbonded prestressed concrete. Next, we will come back to the very important, that is axial or concentric prestressing. Axial or concentric prestressing. Okay. So what is the meaning of axial or concentric prestressing? So let me explain this terminology, with a diagram. So let us draw the longitudinal section of prestressed concrete beam. Okay, so there is a longitudinal section of prestressed concrete beam, and this will be the centroidal axis of a concrete section. Centroidal axis of a concrete section. Okay, to this I am going to induce the tendon through the centroidal axis of the section. Okay, in which it will be anchored. Okay, so what you have been learned from this, when whatever the tendon you are going to embed inside the concrete, if that particular tendon passes through the centroidal axis, so that particular stressing or pre-stressing is called as axially or concentric pre-stressing. Did you get my point? Axial or that means whatever the pre-stressing I am going to induce through the tendon, whatever the pre-stressing I am going to induce, this is what the pre-stressing force. So those pre-stressing force which I am going to induce through the tendon, those tendon or that tendon will pass through the centroidal axis of the section. So this type of pre-stressing is called axial or concentric pre-stressing. Did you get my point? Axial or concentric pre-stressing. So let me go further. Next is eccentric pre-stressing. Eccentric pre-stressing. Okay, so now consider a same diagram. So let me draw the longitudinal section of a PSC beam. Okay, and this will be the neutral axis. Now, let us try to provide the tendon. Let us try to provide the tendon with some eccentricity. Let me denote this word by E. Okay, let me provide the tendon inside the concrete. Okay, with an eccentricity E. Okay, and this has been pre-stressed with a pre-stressing force of P. So now, what is the meaning of eccentric? Okay, now, whatever the tendon that will be embedded inside the concrete, which is embedded in such a way that, which will be away from the centroidal axis, that particular distance is called eccentricity. So this is called eccentric pre-stressing and this is called axial pre-stressing. This is concentric or axial pre-stressing and this will be called as eccentric pre-stressing. And this terminology is very, very, very important because Next, in this particular module itself, we are going to start analyzing the various pre-stressed concrete sections. In that, these two will play a very important role. In the problem, they might have mentioned axial pre-stressing, eccentric pre-stressing, like that. Okay, so the analysis will also vary depending upon the concentric pre-stressing and eccentric pre-stressing. Okay, so we'll explain that how exactly it will vary when the problem starts, because the stress distribution in these two will vary. Okay, in concentric pre-stressing, the stress distribution is different. In eccentric pre-stressing, the stress distribution is different. Okay, that I am going to explain when the problem starts. Is it clear? Fine. So like this we are going to embed the tendon. So one more terminology I should mention here. Okay, already been located over there. That is eccentricity. So let me define this eccentricity. It is a very, very important terminology. Okay, because always we used to calculate this eccentricity in the problem. So that's why I will define it. Eccentricity is defined as it is the distance between centroidal axis of the section to the centroidal axis of the tendon. So that particular distance is called eccentricity. I will repeat. It is the distance between the centroidal axis of the section to the centroidal axis of the cable is called as eccentricity. That means at what particular distance, okay, I am going to induce the pre-stressing force through the tendon to the centroidal axis of the section. It may be rectangle, it may be symmetricalized section, it may be unsymmetricalized section. Okay, that means in rectangular section it will be different, in symmetricalized section it will be different, in unsymmetricalized section it will be different. So we need to calculate that eccentricity. Okay, why? Because at what particular distance this pre-stressing force has been induced through the tendon. So this plays a very, very important role from a central axis of the section. Is it clear? So these are all some of the terminologies you need to remember. Okay. So in order to be thorough in the design of pre-stressed concrete elements. Why? Because all these terminologies I am going to use in the entire course of a design of pre-stressed concrete elements. Hope the concept has been clarified. Okay, so this is the terminology. These are the terminologies used. There are several terminologies are there, like full pre-stressing, partial pre-stressing, all those things. So those are I am going to explain as the thing. Okay, full pre-stressing means inducing the pre-stressing in such a way that no tensile stresses are developed. It is called full pre-stressing. Okay, partial pre-stressing means inducing the pre-stressing in such a way that some amount of tensile stresses will be developed. Okay, that is what partial pre-stressing. Okay, so like this, these are all the terminologies we are going to use in the design of pre-stressed concrete elements course. So with this, I will move further. So now let us move on to the very important topic, that is types of pre-stressing system. Types of pre-stressing system. Okay. Types of pre-stressing system. Types of pre-stressing system. Okay. And as an examination point of view, this topic is very, very, very important. And also as a concept wise also, Okay, it is very, very important because in the last session I've been told so many anchorages out there. Okay, so that I'm going to explain here also. Okay, and also from the examination point of view, these types of prestressing system is very, very important. So now let us get into the first one, that is pre-tensioning prestressing system. Pre-tensioning prestressing system. So let me go with this. Or how to do the pre-tensioning prestressing system. So let us know this. Okay. So first let me go with this pre-tensioning. So this pre-tensioning prestressing system developed by Hoyes. Hoyes is a person who has developed this pre-tensioning prestressing system. Okay, and also this pre-tensioning system is also called as long line pre-tensioning system. Long line pre-tensioning system. So let us know what is the meaning of this and how this pre-tensioning system has been developed. Okay. So now let me draw the diagram. Okay, and also I can see that figure. So let me draw this. Let me draw the casting bed first and the abutment. And this will be made up of concrete, and this will be made up of concrete, and this will be placed, and these two abutments are placed several meters apart. Okay, and this will be purely of concrete, and this will be purely of concrete. In the last class also I have been written. So precasting bed and abutments. Okay. Okay, and this will be completely a concrete. Okay. So now let me place a number of mounts here. Okay. Let me place a number of mounts. Number 1, number 2, okay, number 3, like that. Okay, I can develop. I can draw a pre-tensioning system. Okay, so 3 number of modes I can draw properly. So with this space. Okay. So these are the molds have been placed, and into this let me place a first tendon. Let me place a tendon. Okay. And as I stated, these tendons will be okay, anchored. Will be anchored. Okay, you can see this will be anchored. Okay, and the next, and this anchored at one end, and next, in order to induce the pre-tensioning, so this will be connected to the hydraulic jack. So this will be connected to the hydraulic jack. Okay. So it's the same thing. In the last class I have written one mode, now I have written number of modes. Okay. So now what is the principle behind this long line pretensioning system, or what ideas came to the authors to develop this pretensioning system? Let me explain. So in this long line pretensioning system, the very first thing you need to understand here is you can produce a number of pretension prestress beams. You can produce number of pretension prestress beam at a time. Okay, like that, or hence these abutments are placed several hundred meters apart. Okay, and the next, the mounts are being placed, and the next, the tendons are stretched, and it will be anchored at one end, and it will be connected to the jack, a mechanical jack at other end. Is it clear? Next, as I stated, the concrete will be poured inside this. Okay, the concrete will be poured inside this. Okay, and allow it to get cured, and allow it to get cured for number of days, and allow it to get cured for number of days. Later on, after concrete attain a sufficient strength, that means you need to wait till the concrete attains sufficient strength. When the concrete will attain sufficient strength, the concrete will attain sufficient strength at an age of 28 days. Later on, you need to operate a jack, okay, in such a way that, okay, the pretension will be induced. The pretensioning will be induced. Okay. And the next part, as you know, this will be cut at the either ends, so that number of pretension beams, can be developed with this RS long line pretension. So that's why the terminology long line, that means number of the pretensioning systems you can develop. Is it clear? Okay. And also one more important thing you need to remember here is, and you can see one tendon will be stretched, okay, between the abutments, so that you can induce the pretension inside the pretension or the concrete beam, okay, at a time. So you need not to apply a pretension for this beam, and later on for this beam, and later on for this beam. Okay, so just stretch a tendon and then it is apart, okay, and impart this prestressing force, pour a concrete, okay, and allow it to get hardened, and later on, okay, you can remove the jack after the concrete has attained a sufficient strength, okay, and later on you can cut it. So that means this one tendon wire which has been stretched will serve the purpose. Is it clear? Is it clear? Okay. And also, okay, you can see here, and this is the concrete. Okay, after attaining these things, you can develop this RS long line pretensioning system. And also, you can see here, a very important thing I want to explain here is coming to the jack part. Okay. So here, whatever I have been written is manual. There will be two types of jacks. Okay. One is hydraulic jack. Through the hydraulic jack, the tensioning will be induced. Okay. So as I stated, okay, as I want to explain here, so there will be various types of tensioning devices are available. Various types of tensioning devices. Number one, mechanical tensioning device. The mechanical tensioning devices will be done through various things. Number one, with the help of screw jack. Number one, okay, whatever the thing has been done, it is a screw jack method. Okay, through this the jacking will be done. Okay, and also with a gear transmission system. Gear transmission system. Okay, like that, weight with pulley or without pulley transition. So these are a number of mechanical devices available to induce tensioning inside the tendon. So whatever I am doing, I can say is a screw jack method. So through the screw jack I am going to induce. Or else we can also go with one more thing that is called hydraulic jack device. Okay, hydraulic jack device. So the most commonly used tensioning device in the prestressing concrete or system is hydraulic jack device. You can see in the photo. Okay, the hydraulic jack device. Okay, have been showcased over there. That hydraulic jack device will be used in order to tension the tendon. Okay, whatever the tendon that will be embedded in the concrete. So those tensioning will be done, okay, using this hydraulic jack. And also please remember, okay, and these devices will also be used for post-tensioning prestressing system. Okay, which I am going to explain next. Okay, and the next is electrical tensioning device. Also, we are going to use the electrical method of tensioning. How? Whatever the wire that has been stretched, okay, that will be, or what I can say, the very best thing is thermo-prestressing. This is called thermo-prestressing. In this, these wires are stretched and electrically heated. These wires are stretched, anchored and electrically heated. So by this they are going to induce the method of prestressing, and the method of prestressing will be done is called thermo-prestressing method or electrical prestressing. Did you get my point? And one more way they are going to use is chemical way of tensioning. So chemical way means they are going to use expansive cements. Expansive cements. By using the expansive cements, those chemical interaction will induce the tensioning in the tendon by varying the curing conditions. So by varying the curing condition inside the concrete, by using the expansive cements, okay, we can induce the tensioning. So by this number of methods, we can go ahead to induce the tensioning in the tendon. So what have been drawn here is screw jack method or mechanical method. Okay, and whatever the photo have been shown here is hydraulic jack device. So these are all the various tensioning device I am going to use in order to tension the tendon. So hope the concept has been clear. So this is what the system developed by iron. Okay, and this system serve the purpose in such a way that we can develop number of pretension prestressed beams at a time. Okay, and mainly these systems will be predominantly used in development of railway sleepers. Railway sleepers. So hope you know that whatever the Indian Railway now they are using, all those railway sleepers will be of pretension prestressed concrete beams. Okay, all the railway sleepers are pretension prestressed concrete beams. So those railway sleepers, okay, instead of casting one by one, they are going to cast the number of sleepers at a time. Number of sleepers at a time. So this concept has been developed by Hoyes. So that's why it is called Hoyes pretensioning system. And also the advantage in this system is we can tension the tendon, okay, at a time. Okay, so no need of one by one tension. So that whatever the tension that will be induced in each of the beam will not vary, will be stressed at a time. So this is regarding your OS long line pre-stressing system or pretensioning system. So we will move on further. Let me go with the post-tensioning system. Let me go with the post-tensioning system. So now the number of post-tensioning systems are there. Okay. So now the very important thing we need to understand here is, there I have explained the tensioning devices. So before going to the post-tensioning system, let me know the various anchorage devices, because in post-tensioning system we are going to use, okay, the different types of anchorages in each of the post-tensioning system. There will be different types, 4 types of post-tensioning system. In 4 types of post-tensioning system, whatever the anchorage I am going to use will be different. Okay, the very first one is wedge plates or wedge actions. Okay, so this is the first anchorage device. Okay, wedge action or wedge. Okay, so the wedge action will produce the, okay, friction grip. You can see here in the photo which I have been showcasing on the top. So these are all called the, okay, the anchorages. You can see these are all the cones. You can see the conical shaped cones, and this is the widely used wedge cones used in one of the type of post-tensioning system. In one of the type of post-tensioning system, so these wedges, okay, so these wedges are widely used. Okay, and in the bottommost figure you can see how it has been anchored. You can see at the ends. You can see at the ends. Okay, how it has been anchored. Okay, the number of wires has been accommodated inside that, and this is the sheet. Okay, this sheet. Okay, inside it will be there in such a way that all the tendons will be housed inside this. Okay, and this will be the trumpet. Okay, and this will be what I can say called the plate. Okay, the end plate. Okay, to this end plate, whatever have been connected is called wedges. Okay, so these wedges, okay, will be used to anchor the number of wires or the tendons. You can see clearly, okay, from the photo. Why? Because by simply, okay, coming to know by the text you cannot know, by seeing through the figure you can understand more thoroughly. Here, whatever have been accommodated have been magnified and shown. Okay, the top figure have been magnified. So those are all called the wedges. Is it clear? Fine. So next we will move on to the one more type of anchorages, that is called direct. Okay, that is called direct bearing. So this is one more type. Okay, this is called direct bearing. So now, instead of going with the wedges, you can see here whatever the tendons that has been stretched, okay, and entire that number of wires, you can see that will be buttoned. That means it will be riveted or bolted. You can see over there. All the ends of wires will be buttoned. That means that wires will be bolted or riveted. This is one more method of anchoring. This is called direct bearing system. And this direct bearing system is predominantly used in one of the company of prestressing. This is called BBR post-tensioning system. So So PVR company, it is one of the top MNC which produces or does lot of post-tensioning systems or produces more post-tensioning pre-stressed concrete beams. Next, the one more is looping the wires. One more method is looping the wires around the concrete. Looping the wires around the concrete. So this is the one more way you can see looping the wires. Okay. So here you can see how it has been anchored. This is one of the slab that we showcased. Okay. In this particular slab, all the wires, okay, I am going to connect it to the one of the reinforcement by forming a loop. That's what it's called, loop forming or looping the wires. That means winding all those wires around the concrete. So this is the one point. So these are the anchorage systems which I am going to use in the 4 types of post-tensioning system. So let me go with the first one. So the first one is called, the very predominantly uses precinate post-tensioning system. Precinate post-tensioning system. Okay. So this precinate post-tensioning system is widely used in India and European countries. Okay, and as you know, Pretension, who is the father of pre-stressed concrete, who has done a tremendous research on this developing this anchorage system, and also I have showcased one of the figure. Okay, that is Pretension T system anchorage. So this anchorages, they have been widely used in this system. Okay, and please see the figure how the concept has been developed. You can see over there. Okay, it comprises of a cylinder. Okay, it comprises of a cylinder. You can see over there with a conical interior. A cylinder with a conical interior. Okay, why? That conical interior will be made in such a way that number of high tensile wires will be passing through the wedges, and those through the wedges, you can see the spread one. Okay, the small one is called wedges. Okay, and those high tensile wires will be passing through the wedges, and those high tensile wires again will be passing through that cylindrical or whatever the container, cylindrical container with the conical shape. Okay, and finally it will be went through the duct former. Okay, and it will be anchored. Okay, and this is the system how they have been developed. Okay, in order to what I can say the function of post-tensioning system. Okay, one cylindrical container and one steel wedge. Okay, a conical wedge, through that high tensile will be passed, okay, and it will be anchored. Okay, and those conical plug, or what I can say the wedge, okay, it will be anchored longitudinally. It will be anchored longitudinally. Okay, and also through this system we can work with double acting hydraulic jack system. That means whatever I have mentioned over there, that is we can work with hydraulic jack system. Okay, in order to tension the tendon. So like this, okay, this is the way they have been developed the Precinate anchorage system or post-tension system. We will move on to the next. The next is Gifford-Woodall post-tensioning system. Gifford-Woodall post-tensioning system. Okay. So now once again you can see over there with the same thing. As the diagram itself it is indicating. Okay. I return the side view and also you can see over there. It comprises of a steel split core. First, it comprises of steel split core. Through that steel split core, you can see a cylindrical female cone will be inserted. Okay. And through that split core and the cylindrical female cone, that high tensile wire will be passed. That high tensile wire will be passed. Now the question will come. How it has been anchored? You can see from the figure that arched portion, okay, that will be, okay, that is called bearing or end plate. Okay, that end plate or bearing plate will be provided. So that bearing plate will be act as an anchor. So through that, okay, bearing plate, all that is high tensile will be anchored. So this is the way the Gifford Udall has been developed. Okay, you can see over there. And all those wires, as I stated, will be, okay, embedded inside the metal sheet. I will show you what is that metal sheet. You can see here. You can see here. See, this figure is clearly, you can see here, whatever the high tensile wire or tendon which will be inserted, so that entire thing you cannot see here. So that entire high tensile wire will be embedded inside the metal sheet. So this is what metal sheet. So this is what metal sheet. You can see here. So this is what metal sheet. So the entire wires will be not exposed. It will be embedded inside the metal sheet. So that you can place firmly or embedded inside the concrete properly. Okay. Next. Now we will move on to the next one. That is, this is regarding Gifford-Udall system. Next we will move on to the next one. That is called Lee-Meccal system. Lee-Meccal system. So here also you can see in the diagram what he has made here is he can, instead of going with the wires, what he showcased here is a high tensile rods of 12 to 40 mm. High tensile rod of 12 to 40 mm will be sent through that or embedded through the concrete. That is one thing. And also you can see at the end there will be end plate. Okay, as I stated in the last, that is Gifford-Udall system. Through that end plate you can see the rod has been, okay, extended or stretched, and this rod will be finally anchored by a washer and a nut. I will repeat. Okay, this tendon will be stretched through the bearing plate, and finally it will be anchored through or by washer and a nut. Okay, that is what was school, or washer nut system. So this is the methodology that being followed. Okay, or they have been followed in the Lee-Meccal system. Last one is Magnell-Bratton system. Magnell-Bratton system. Okay. So now, in Magnell-Bratton system, he has adopted different methodology. So you can see from the figure, he has used three devices. One is to the concrete, he has embedded, he has casted or with a distribution plate. In a proper design location, that distribution plate will be inserted. And later on, a sandwich plate will be there. Also you can see a sandwich plate. Okay, at the end it will be having a C wedges. Now, the number of wires or group of wires will be embedded between those sandwich plates. The speciality of this Magnell-Bratton system is a group of wires, it may vary from 2 to 64 number of wires can be embedded inside the sandwich plate. And those sandwich plate finally it will be inserted in the distribution plate, and finally it will be, the system will be generated. So that means what I am trying to show here is each personality they have been used a different methodology to anchor the high tensile wires or cables or antennas. Hope the concept has been clear. Okay, or whatever the systems, okay, they have been discussed. So today we have been discussed the pre-tensioning system, post-tensioning system, and the various terminologies. Hope the concept has been clarified, and by visualizing these photos, I think hope you want your mind, okay, how exactly the pre-tensioning and post-tensioning looks. With this, I am going to end the session of today's. Thank you.